A Honda 3000-watt portable generator is tripping its ground fault circuit interrupter, or GFCI, when a microwave is used. An outlet tester shows an open ground condition. A Honda repair person has stated that the open ground is normal. Let's consider some possible explanations. Firstly, it could be a faulty generator outlet. The GFCI in the generator outlet may be defective or malfunctioning. This could cause it to trip unnecessarily, even with a properly grounded circuit. Secondly, there could be inadequate grounding. The generator itself may not be properly grounded, which could lead to an open ground on the outlet. Make sure that the generator is connected to a reliable grounding source. Thirdly, it could be a microwave issue. The microwave itself may have a ground fault, which could cause the GFCI to trip when used on any outlet. Try using the microwave on a different, known good circuit to rule this out. Fourthly, it could be an intentional open ground by Honda. Honda may intentionally leave the equipment ground wire disconnected from the outlet. This is highly unusual and potentially hazardous. Leaving the equipment ground wire disconnected violates electrical safety codes and can pose significant risks. It creates a shock hazard because the lack of a ground path increases the risk of electrical shock in the event of a fault. It also creates a fire hazard because if a fault occurs, the current may not have a proper path to ground and could cause overheating or a fire. Here are some recommended actions. Firstly, verify proper grounding. Ensure that the generator is connected to a good grounding source. Secondly, inspect the generator outlet. Have the GFCI in the generator outlet tested or replaced if necessary. Thirdly, consult NEMA to confirm the validity of the Honda repairman's claim and seek their guidance on the appropriate safety measures. Fourthly, do not leave an open ground. If the claim is true, consider modifying the outlet to connect the equipment ground wire to the chassis of the generator. This should be done by a qualified electrician. The open ground problem on the Honda generator is a potential hazard. While the repairman's claim is unusual, it should be investigated further. It is crucial to ensure proper grounding and adhere to electrical safety codes for the safety of those using the generator. For proper grounding, you need to understand the principles of electrical grounding. Electrical grounding provides a safe path for fault current to return to the source, typically the generator in this case, tripping a circuit breaker or GFCI and preventing electrical shock hazards. In a properly grounded system, all metallic parts of electrical equipment that are likely to become energized during a fault, such as the generator's chassis and the metal enclosures of connected appliances, are connected to a grounding electrode, like a ground rod. This connection creates a low impedance path for fault current. The ground fault circuit interrupter, or GFCI, is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing to and from an appliance or device. If there is a difference of more than a few milliamperes between the incoming and outgoing current, it indicates that some current is leaking to ground, potentially through a person. The GFCI trips, quickly cutting off the power to prevent a shock. Regarding the microwave, a microwave oven is a high-power appliance that can draw a significant amount of current. If the microwave has a faulty component, such as a failing magnetron or a damaged capacitor, it can cause excessive current draw or create a ground fault. This ground fault can then cause the GFCI to trip. Even if the microwave works on other non-GFCI protected circuits, it doesn't necessarily mean that it's not contributing to the problem. GFCI outlets are more sensitive to ground faults than standard outlets. When testing for an open ground, an outlet tester is a simple device that plugs into an electrical outlet and uses lights to indicate whether the outlet is wired correctly. An open ground means that the grounding conductor is not properly connected, which can create a safety hazard. If the outlet tester indicates an open ground on the generator, it means that the grounding wire from the outlet is not connected to the generator's chassis or grounding system. The National Electrical Manufacturers Association, or NEMA, is a trade association that sets standards for electrical equipment. They can provide guidance on the proper grounding practices and safety measures for generators. Consulting with NEMA can help determine whether Honda's claim of an intentional open ground is valid and what steps should be taken to ensure safety. If Honda has intentionally left the equipment ground wire disconnected from the outlet, it would be a violation of electrical safety codes and could create a dangerous situation. Connecting the equipment ground wire to the chassis of the generator would provide a safe path for fault current and help prevent electrical shock and fire hazard. This modification should be done by a qualified electrician to ensure that it's done correctly and safely. The NEC, or National Electrical Code, is a widely adopted standard for safe electrical installation. It provides detailed requirements for grounding and bonding of electrical systems to ensure safety. Article 250 of the NEC covers grounding and bonding requirements. It specifies how grounding electrodes should be installed, how equipment should be grounded, and how bonding should be done to create a low impedance path for fault current. Section 250.4 clarifies the general requirements for grounding and bonding. It states that electrical systems should be grounded in a manner that limits the voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines, and that stabilizes the voltage to ground during normal operation. Section 250.20 specifies the systems that are required to be grounded. This includes alternating current, or AC, systems that operate at 50 volts to 1000 volts and supply premises wiring. Section 250.30 covers grounding requirements for separately derived systems, such as generators. It specifies how the grounding electrode conductor should be sized and connected, and how the generator should be bonded to the grounding electrode system. In general, the NEC requires that generators be grounded in the same manner as other electrical systems, with a grounding electrode conductor connected to a grounding electrode and all non-current carrying metal parts bonded together. This ensures that there is a low impedance path for fault current to return to the source, tripping a circuit breaker or GFCI and preventing electrical shock hazards. When dealing with GFCI tripping issues on generators, it's essential to follow a systematic troubleshooting approach. Firstly, start by checking the generator's grounding. Ensure that the generator is properly connected to a grounding electrode, such as a ground rod, and that all grounding connections are tight and corrosion-free. Secondly, inspect the GFCI outlet on the generator for any signs of damage or wear. Test the GFCI outlet using a GFCI tester to ensure that it trips properly when a ground fault is simulated. If the GFCI outlet is faulty, replace it with the new one. Thirdly, check the microwave for any signs of damage or wear. Inspect the power cord for any cuts or abrasions and make sure that the plug is in good condition. Test the microwave on a different, known good circuit to see if it trips the GFCI on that circuit as well. If the microwave trips the GFCI on multiple circuits, it likely has a ground fault and should be repaired or replaced. Fourthly, if the generator has an open ground, it's essential to correct this issue before using the generator. Consult a qualified electrician to determine the cause of the open ground and to make the necessary repairs. In some cases, it may be necessary to connect the equipment ground wire to the chassis of the generator to provide a proper grounding path. Fifthly, if the GFCI continues to trip even after addressing the grounding and equipment issues, there may be a more complex problem with the generator's electrical system. In this case, it's best to consult a qualified electrician or generator technician for further diagnosis and repair. Additionally, it is critical to take appropriate safety precautions when working with electrical equipment. Always disconnect the generator from the power source before performing any maintenance or repairs. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, when working with electrical components. If you are not comfortable working with electrical equipment, consult a qualified electrician for assistance. Let's discuss bonding, which is another important aspect of electrical safety. Bonding involves connecting all non-current carrying metal parts of an electrical system together to create a low impedance path for fault current. This helps to ensure that fault current will quickly trip a circuit breaker or GFCI, preventing electrical shock hazards. In the case of a generator, bonding involves connecting the generator's chassis, the metal enclosures of connected appliances, and any other metal parts that are likely to become energized during a fault. This can be done using bonding jumpers, which are short lengths of wire that connect the metal parts together. The size of the bonding jumpers should be appropriate for the size of the generator and the amount of current that it is likely to carry. The NEC provides detailed requirements for bonding electrical systems. It specifies how bonding jumpers should be sized and installed and how bonding connections should be made. Article 250 covers bonding requirements. It states that all non-current carrying metal parts of an electrical system should be bonded together to create a low impedance path for fault current. It's also important to note that generators are often used in portable applications such as camping, construction sites, and emergency power situations. In these situations, it's especially important to ensure that the generator is properly grounded and bonded to prevent electrical shock hazards. When using a generator in a portable application, it's recommended to use a ground rod to provide a grounding electrode. The ground rod should be driven into the earth near the generator and connected to the generator's grounding terminal using a grounding electrode conductor. Additionally, any metal equipment that is connected to the generator should be bonded to the generator's chassis using bonding jumpers. For instance, if a metal tool is plugged into the generator, the tool's metal enclosure should be bonded to the generator's chassis to provide a safe path for fault current. Proper grounding and bonding are essential for electrical safety when using a generator. It's important to follow all applicable electrical codes and standards to ensure that the generator is installed and used safely. Consulting a qualified electrician can help ensure that the generator is properly grounded and bonded and that all electrical connections are made safely and correctly. Additionally, consider that the size of the generator may be a factor in the GFCI tripping issue. A 3000 watt generator has a limited capacity, and if the microwave is drawing too much power, it could overload the generator and cause the GFCI to trip. Check the microwave's power rating and make sure that it's within the generator's capacity. If the microwave is drawing too much power, try using a smaller microwave or reducing the load on the generator by turning off other appliances. Another possible cause of GFCI tripping is a neutral ground fault. This occurs when there's an unintended connection between the neutral conductor and the ground conductor. A neutral ground fault can cause current to flow through the grounding path, which can trip the GFCI. To check for a neutral ground fault, use a multimeter to measure the resistance between the neutral conductor and the ground conductor. If the resistance is low, it indicates that there's a neutral ground fault. Neutral ground faults can be caused by damaged wiring, loose connections, or faulty equipment. If you suspect a neutral ground fault, consult a qualified electrician to diagnose and repair the problem. Furthermore, consider the type of GFCI outlet that is installed on the generator. There are two types of GFCI outlets, Class A and Class B. Class A GFCI outlets are designed to trip when there's a ground fault of 5 mA or more. Class B GFCI outlets are designed to trip when there's a ground fault of 20 mA or more. Class A GFCI outlets are typically used in residential and commercial applications where there's a high risk of electrical shock. Class B GFCI outlets are typically used in industrial applications where there's a low risk of electrical shock. If the generator has a Class B GFCI outlet, it may be more prone to tripping due to nuisance trips. In this case, it may be necessary to replace the Class B GFCI outlet with a Class A GFCI outlet. Finally, let's not forget about the importance of regular maintenance for generators. Regular maintenance can help prevent electrical problems and ensure that the generator is operating safely and efficiently. Maintenance tasks should include checking the grounding connections, inspecting the wiring, cleaning the generator, and testing the GFCI outlet. It's also important to follow the manufacturer's recommendations for maintenance and to consult a qualified technician if you have any concerns. By following these steps, you can help ensure that your generator is operating safely and that the GFCI is functioning properly. If you are not comfortable working with electrical equipment, it's always best to consult a qualified electrician for assistance. In summary, the open ground issue on the Honda generator is a potential hazard that should be investigated further. While the repairman's claim of an intentional open ground is unusual, it's important to verify this claim and to take appropriate safety measures. Ensure proper grounding, inspect the GFCI outlet, consult NEMA, and consider modifying the outlet to connect the equipment ground wire to the chassis of the generator. By following these steps, you can help ensure the safety of those using the generator.